Okay, now that we've done some absolute value problems, we've done equations, we've done some inequalities, we're going to talk about the absolute value tolerance problems. Now, tolerance problems are a little bit more specific, but it still deals with absolute value. Because we're talking about tolerance, meaning how much can we be off by? How we have to be within a certain range. And here's an example problem that we can talk about so we can see exactly how this tolerance thing works. Okay, so the ideal length of one type of model airplane is 90 centimeters. The actual length may vary from the ideal by at most 5/100ths of a centimeter. So what are the acceptable lengths for the model of the airplane? We want to write and solve an absolute value inequality for this problem. Well, most of these problems, actually all of the tolerance problems, you can do using a simple guideline. It's always going to be the absolute value of the actual, what the actual length is, minus what the ideal is, the ideal length. And that has to be less than or equal to the tolerance. Sorry about that. As you can see, math, good. Spelling, not so good. Okay. So, in this case, the actual, which is the thing that we don't know, that's going to be our n, minus the ideal. Well, we know the ideal length is 90. Okay? And that has to be less than or equal to the tolerance, which in this case is 5/100ths of a centimeter. So now we've written our absolute value inequality. All that's left to do is to actually go ahead and solve this. So when we solve this, if you remember, absolute value requires us to write two inequalities to solve it. So the first one is exactly what you see here, right? Just without the absolute value. And the second one is the one, if you remember, we have to write what's inside, okay? Then we reverse the inequality sign, and then we change the, but in this case, the tolerance to a negative number. Okay, now we would go ahead and solve. So in this case, we have to be greater than, again, this is a negative number, so this is going to be 89 and 95/100ths. And over here when we solve, we have the 90. So your n has got to be less than or equal to 90 and 5/100ths. So when we're looking for what the range has to be, this is that time again. If you watched the last video, you'll see this is when we're going to actually reverse the direction of this. We just want to rewrite this one so it looks like this. Okay, and then what we can do is we can bring this one down. Right, you remember doing this, and then we kind of match up the ends, and there we have our absolute value inequality solved out so that we have a range. Again, because we can do this and we have the less thans, this means that this is going to be an and graph, right? So we know that we have this point, which is our 89 and 95/100ths. We have this point, which is our 90 and 5/100ths. And we have everything in between these are all acceptable values, right, for the actual length of this model airplane. How you do a tolerance problem.